A quick overview of where we're going and sort of where this beginning of Chapter 1 fits in is, as I mentioned with the syllabus and the welcome, the big point of this course is hypothesis testing. And in hypothesis testing, what we're trying to figure out is, given data, given data, how likely is it that these data could have come from a hypothesized distribution. Okay, distribution is just a population. So really a hypothesized distribution / population. Okay, so that's the question. I mean, through most of this course, we're just trying to answer that question. How likely is it? And what we're going to say is, if there is less than a 5%, move this down a little bit, a 5% chance that these data, okay, that's what we actually collected, these data came from the hypothesized, hypothesized population, then we will conclude, okay, or infer, that's the inference idea, conclude, infer, that the data came from a different population. Okay, so that's what we're doing every single time, and the key is going to be this 5% for us. Now, that's an arbitrary number. We will hopefully, if the website's back up that has the game, you'll be able to participate in this game to kind of see where and why that 5% might make sense. But now let's kind of go to that question and sort of the rest of the chapters in this course. So again, Chapter 1, that's all about data. And then Chapter 2 is really this intro to inference, this idea, trying to get us to internalize how we answer a question like this. So given data, how likely is it that these data could come from a hypothesized distribution or population? In Chapter 2, we'll look at kind of where these populations could come from, or how we could think about these populations. But then the rest of the chapters, we're pretty much, again, in answering this question, we're really asking our question about two variables. So, for instance, the example I usually use is like smoking and cancer, and the question of whether one seems to have some sort of relationship with the other, and that seems to be a pretty accepted fact these days, is that smoking, if you know, and you can look at it this way: if I ask you, are you a smoker or not, and then you answer one of two different ways, either yes or no, well, your answer will inform me as to the likelihood of you getting lung cancer later. And so in that way, they're very linked. They're very dependent on each other, in that if you tell me you're a non-smoker, well, then sure, you might get lung cancer, but I think your chances are way lower. If you tell me you are a smoker, in particular maybe a heavy smoker, I'm going to assume that you have a much higher chance of having lung cancer later on in life. And so you see, this is the idea of dependence. If I get the information about one variable, okay, whether you or not you smoke, your smoking status, if I get information about that variable, it will absolutely change or color my prediction about another variable, which would be whether or not you will get cancer at some point, well, lung cancer at some point in your life. And so I use, I can use one variable to help me predict something about another variable. And the thing is with that, so we have usually we would call it something like a explanatory variable. That's the one we usually gather to then make a prediction. So explanatory variable. And then I'm going to make a box here. So we've got a 4-part box, and then here I have the response variable. And so our explanatory variable, like, do you smoke or not? What's your smoking status? And then a response variable, whether or not, or really what are your chances of contracting cancer later on in life? Well, now, the smoking, yes or no, that's what we would call a categorical variable. And so I'm going to put that here, that you might have a categorical variable. And that is categories, just like it sounds. But another possibility is you could have a numerical variable. And that would be things like height and weight and so forth. Well, so the explanatory variable could either be categorical or numerical. Similarly, the response variable could be categorical or numerical. And when we go through this course, it pretty much comes down to the different chapters. So this is chapter 3. Then, and so we start there, and those are usually what we call count data. Then we will move to chapter 4, where, whoops, going the wrong way there, where the explanatory variable could be categorical, but the response variable is numerical. A typical example I use for that is suppose you're trying to look at fertilizers. I may have 3 types of fertilizers that I want to look at and analyze. So the fertilizer type is the categorical explanatory variable. But then how would I measure my success, or measure, what am I measuring as my outcome, my response variable? Things like bushels per acre or something like that. Well, that's a very numerical type of number. And then if they're both numerical, that's our chapter 5. That's the linear regression type of things. So our 3, that's going to be this thing called chi-square. Okay, or chi-square like that. Greek letter chi. 4, chapter 4, that's going to be what we call analysis of variance. You usually just see it written as ANOVA. Chapter 5 is least squares. And that you're a little more familiar with usually as far as scatter plots, that kind of thing. And then actually the least squares will be a little bit of 6 as well. So this is really 6 and 5. But then finally in the last part of chapter 6 we go to logistic regression. So least squares regression. I should have put regression with that as well, but logistic regression, that's finally a categorical response with a numerical input. Now that could be something like near and dear to your all heart might be something like test scores. So numerical explanatory variable might be, things like the SAT or ACT or something like that. Nursing types, it could be things like NCLEX and all that. But then the response variable might be with like SATs and ACTs and so forth. The probability, for instance, you'd look at, do we think that person will get in or not get in to a school, or did they or didn't they? And so then that response is really a 0 or a 1. It either happened or it didn't. And then we can start asking questions about that situation, and that we use this logistic regression. And then again, least squares from chapter 5. But these are all of these chapters, we're just answering that same question each time. We're saying, well, given the data, how likely is it these data could have come from a hypothesized population? So for each of these, we'll have to identify that population that we're talking about. But in the end, we just use a different test because we have different types of data. And so we'll go through these different tests. And the hope is by the time we get through all these tests, you actually begin to have some notion of what this hypothesis testing is. All right, so we'll call that good for this video and move on to others.